So we're on Coulomb's law, number 2. Are you moving with me? They say determine the electrostatic force as well as the gravitational force between two electrons in an atom when they are 5 times 10 to the minus 10 meters apart. So it's two little electrons, electron 1 and electron 2, and they are a distance of 5 times 10 to the negative 10 meters apart. So what do we need here? We need the charge on the electron, which is negative 1.6 times 10 to the negative 19 coulombs. And we're going to need the mass of the electron. So what is the mass of the electron?
It is 9,11 times 10 to the power of negative 31 kilograms.
Okay? Because they want us to get the electrostatic force in number A, they want us to get the electrostatic force, and in number B they want us to get the gravitational force. So in one we're going to use Coulomb's law. Can I say Q1 squared? Because they're two electrons, divided by the distance squared. And in the other one, we're going to use gravitational force. Can I say M squared? And distance squared. I'm giving you some time to get to that. Are these numbers correct?
Yes.
And that number is correct?
Yes.
Okay, maybe I've made a mistake. Let me try again. So it's 6.67 exp negative 11 times 9.11 exp negative 31. That must be squared divided by 5 exp negative 10, that must be squared, equals 2,21 times 10 to the minus 52.
Yes.
Oh, minus 52 newtons. Okay, and it's gravitational force, always attraction. Good, so we're ready to go to number 3. I think number 3 is going to ask me to calculate the net electrostatic force on a specific charge. So the situation is bringing in a third charge now, and we need to get net forces. That complicates matters a little bit, and here it is even more important to get to the direction of the forces. So we're going to go to number 3 now. Okay. The sketch isn't there, so we need to draw the sketch. 3-point charges lies on a straight line. So your diagram will look something like this, where there's a straight line. Okay. And the 1-point charge will be somewhere. The first one is a plus 2 nanocoulomb, and the last one is a plus 3 nanocoulomb. No, sorry, negative 3. Negative 3. nanocoulomb. Q1 and Q2 is 2 centimeters apart, and Q2 and Q3 is 4 centimeters apart. So here somewhere is Q2, which is a plus 1 nanocoulomb. And the distance between those is 2 centimeters, and the distance between those two is 4 centimeters. Okay. So this is Q1, that's Q2, and that's Q3. The centimeters is a problem. What can I change them to? So it's 0,02 meters and 0,04 meters. You know why? 100 centimeters in a meter. So what's the question about? Calculate the magnitude and the direction of the net electrostatic force on Q2 due to the other two charges. So where are we standing? Not the middle. We're standing here. We're standing there. Now we ask ourselves, we need to teach ourselves to ask ourselves, what is Q1 doing to Q2? It's repelling it. So it's pushing it to the right. Am I right? Okay. So it's pushing it. So I need to draw this part. That Q2, and this is the F of 1 on Q2. Okay. What is Q3 doing to Q2? So what is that one's direction? Also in that direction. Am I right to say that? This is where we see that the force of 3 and the force of 1 is going in the same direction. Okay? And if they're going in the same direction, what do I do to get the net force? We're going to add them. Okay. So we need to do this part where we go to Q2 and we ask ourselves, what is Q1 doing to Q2 and what is Q3 doing to Q2? So that we can see whether we must add or whether we must subtract these two forces. How am I going to get the forces? We use Coulomb's law. So the force of 1 is K Q1 Q2 over the distance between them squared. Okay? And the force of 3. It is K Q1 and it's Q2, isn't it? Q2 Q3 over R squared. We can make an R1 and an R2, doesn't matter. Okay. What's K's value? 9 times 10 to the 9. What's Q1's value? 2 times 10 to the negative 9. What's Q2's number? 10 to the negative 9. What's the distance between them? 0,02. That must be squared. Okay, let's Casiofy that. get 4.5
Yes.
times 10 to the negative 5
Yes.
Newton. Okay. Ready to roll? The value of K is 9 times 10 to the 9. You find that on your data sheet. The value of Q2 is 10 to the negative 9. The value of Q3 is, we don't substitute the negative there, so it's 3 times 10 to the negative 9. And the distance between the two? Perfect. Let's Cassiophy that one. Do you get 1.69?
Yes.
10 to the minus 5
Yes.
newtons. Now I'm going to rewrite that formula there. And I'm going to say it is 4.5 times 10 to the minus 5 plus 1.69 10 to the minus 5, and we Cassiophy that. Do we get? And there must be a direction here. Is it to the left or to the right? To the right or towards Q3. Good. Do you need another break? How much break do you need?